Welcome Year 11s to this video. In it I'm going to run through regression, so what regression is, and the particular method of regression that we're going to be using in this course, which is called the least squares regression. So the reason that we're looking at regression now, as you can see, that means fit a line to the data, is that we have established how we can determine if there's a correlation or an association between two variables. And now what we want to do is try and make predictions using that correlation that we've found. In order to do that, we want to fit a line to that data that best fits the data, so that best, encompasses or gives us a model of that data. And there's particular methods in how you can actually fit that line. So for example, you can do that by eye. So you can just sort of judge based on the cluster of dots where the line might go. Or there's more, mathematical approaches, which is the one that we're going to be looking at. So we're going to put a line on that data. We're going to develop an equation of that line. And don't panic because our calculator will do that for us. And then once we've got that equation, then we'll be able to make predictions, and we'll do that in a later lesson. Today, all we want to do is look at how we get that line onto the data. So we're going to be using this particular method, the least squares regression line. And as you can see in the box here, this is the method or how that line is found. So the line itself will be positioned in such a way that will minimize the sum of the squares of the residuals. Now that sounds like a massive mouthful, and you may not be fully aware of what a residual is. So first I'll explain that. And then we'll be able to see what it means by the sum of the squares. So first of all, a residual, if you draw a line on a scatter plot, so you've got one here in green, and you'll also notice that there's dots. So this is where the original dots of the scatter plot were placed. What you can see is there are vertical distances. So this here is a vertical distance between the line and the the line, which is in green, and the actual data, which is the dot itself. I just might go over that. So vertical distance between the line and the data, the actual data itself. Now that there is really a definition of a residual. There's another way to look at it though. The dots here, they're called our actual values. And since our line is going to be used as a prediction, any value on the line is called a predicted value. So since it's a vertical distance that we're looking at, really what we can say is it's the actual RV value. So the actual value here for the RV, which is over on this axis, minus the predicted value, so minus what's on this line, so whatever value is right here, for example, for this particular point. So if we looked at the vertical distance between those two, I can describe it as a vertical distance, or I can describe it as the actual value minus the predicted value. That there is a residual. Now we look at residuals a little bit further in Year 12. We go a bit beyond this course, but the main thing you need to know for a residual is that it's used here to get the least squares regression line. Now, our residuals, they can be positive. So these ones that are sitting above the line, they're going to give us a positive value. Anything that's below the line would actually be a negative residual. So for that reason, when we're looking for the least squares regression line, what your calculator is going to do is it's first going to create a square of the residuals. So each of these, you can see in this particular diagram in the dark green, that's the residuals there, that vertical distance. But notice that each of them, that's the distance there, has been created into a square. That's happened with all of them. So you'll see if the dot, which is in red, if that dot is close to the line, then you've got a little square. If it's on the line, you actually don't have a square at all because the residual would be 0, and you can have a residual of 0. So there's a really tiny square there. But if the dots are really far away from the line, you get a big square. So what we want is this line to be really close to our data. But of course, if it's not a perfect association, it's not going to go through all of the data points. There is going to be a distance between some of the data points and the line. We're trying to really minimize that distance altogether. So what we do is, or what the calculator will do is it'll create a square out of all the residuals and it'll move this line up and down and it will try and find a point where the sum of the squares areas, so the sum of the squares of the residuals is as small as possible. So it's going to try and make sure that the line is close enough to perhaps have the smaller squares that you can, but it's going to be unavoidable to get some larger squares. So it'll position it in a way that will, when we add up all these areas, you get the smallest area in total. Now that would be really hard to do by hand, as you can imagine. So you see this one here has been done electronically, or it's been done on a computer program. And of course our calculator is a computer program. So our calculator is going to do that for you. Now, I haven't mentioned yet, but I will now, there is actually a formula that also will help develop the equation of the least squares regression line. The reason is because there's actually a relationship between the R value, remember that's Pearson's correlation coefficient, we looked at that last lesson, and there's a relationship between that and the what we call the standard deviation of the variables, and also the mean of the variables. So we did the mean and we did the standard deviation back in semester 1. You can obviously calculate them using your calculator. However, with these sorts of questions, you're going to be given the mean and you're going to be given the standard deviation. And what we're going to ask you to do is try and get the least squares regression line, or the equation for it, using those statistics. I'm going to show you how it's done. As you can see, there are actually two formulas. There's one to find B and there's one to find A. And you're probably wondering, well, what is B and what is A? Well, whenever we have an equation of a line, it's written just here. I might write it nice and big though. Whenever we have the equation of a line, a straight line, we have two things really that we need to know. One of those things is called the y-intercept, which we call A, and the other thing is called the slope or the gradient, and that's B. Every time you're trying to find an equation, you're trying to find those two things. Now, you know this already because we did this when we looked at linear equations back in semester 1. So that means we have two formulas here because we have two things we need to find. The first one is the slope. You are going to use that first. You have to do this one first. You're then going to find your y-intercept. The reason you're going to find that second is you'll see you need to use B in the formula. So you're actually going to take your answer that you found for B up here, the slope, and you're going to copy it and paste it into this formula. I mean copy and paste because it might have lots of decimal places, so you don't want to round it off. Let's have a look at how it works. So we've got some data here, and to save you time, I've gone ahead and calculated for you the mean of X. Remember, this is the mean of Y, the standard deviation, we'll just put STDev, of X, and the standard deviation of Y, and also have found for you Pearson's correlation coefficient, so R. Now, these have been rounded off to a certain number of values just to try and keep as much accuracy as we can, but obviously I couldn't give you thousands of digits on the page. So we'll have a look at how it's done. Find the equation, give coefficients to three significant figures. So B is what we want first. And to get B, we want to do R times SY over SX. So R is here, negative 0.998 times SY, here it is here, 12.368. And that's over or divided by 3.742, which is our standard deviation of X. Okay, we'll need to open up our calculators now so that we can get that. Here we go. All right, so negative 0.998 times by 12.368 over, and we've got 3.742. All right, what do we get? Here we go, negative 3.29857. Now, depending on your float, I'll just double check that that's all my digits. I'll just quickly check my settings. Just increase my float. Default and oh, there we go. Notice I changed my float because I noticed it had rounded it off a bit. I increased my float because I knew that this actually continued on a little bit longer. So I'm not doing that because I don't necessarily need to round it off to a particular number, but I want to show you the difference between your float. If I have a lower float, I don't actually see the whole number. This is a much better option. Okay, so if I now go back to my workings, I'm going to write my answer. I don't need to write the whole thing, but I'm just going to recognize, I'm going to demonstrate that it does keep going. I'm not rounding my answer to 3 significant figures just yet. I won't do that until I write my, my actual equation. So just put a line down there just so I can do my next calculation, which is for A, the y-intercept. So this is what my formula looks like. I now will substitute, so the mean of y, which is given to you above. Now I need to put, I'm subtracting, I need to subtract b times x. So since b is negative, I'm just going to put a bracket there just so I can see there are 2 clear negatives, not one, because it's subtracting a negative. Now I'm not going to round that off because I don't want to lose any accuracy. So it's negative 3.2985 and put ... to show that it keeps going. And then the mean of x, which is 7. So like so. Now I'm going to make use of my copy and paste so that I get all of that number. Show you what I mean. So I've got 17.833 minus, just put a bracket in again. You don't have to, but I just think it's a lot clearer if you do. Negative. Oh, actually, I don't need the negative yet. Once I open up that bracket, I've got my cursor inside that bracket. What I want you to do is just press the up arrow so that this number is highlighted. We want that number to be in the bracket. All I want you to do now is press enter and it will copy it into that bracket for you. So this is a function of your calculator that that some of you I think are unaware of, that you can just highlight your previous answer and press enter and it will copy it down. And then times by 7. All right, let's see what we get. 40.923, etc. So let's go back. So remember, this is our A value, 40.923 ... Okay, now that I've got my B and I've got my A, I will get my my equation in this form. Y equals A plus BX. Therefore, all I have to do is put these values in. My A value was here, but I want 3 significant figures. So 1, 2, ... The 9 will stay as 9 since the number after it is 2. I now will put my B value, but you notice it says plus B, and my B value is negative. So I'm not going to write plus negative 3 because that's not very good use of mathematical symbols. That simplifies. When you add a negative, you are subtracting. And so I will write minus 3 point. Remember, I need 3 significant figures. So I'm looking at this part of the number. It's 29. The next number is 8, means that the 29 goes up to 30. And then my x. And there's my equation of my least squares regression line. So you'll get a chance to practice that a little bit using the formula, because remember, there are 2 ways to find this. This is the formula method. You only ever do this method. So only ever use the formula when provided with this information. So you'll be provided with the mean, the standard deviation, and R, and generally you're not provided with this. The reason that it's there really is only because we're going to use that same data with the next method of finding it. So I'm going to use this same data with the calculator method, just so that we can compare and we can see that we do generate actually the same thing. So generally you wouldn't have the data, you'd be given this stuff here, and you'll use that formula to find that equation. Okay, the most common way that you're going to find your least squares regression line is using the calculator. As you can see, we've got the data given to us. Our first step in trying to get it is to get the data into our calculator. We do that in lists and spreadsheets. Now I have done that already. So if you want to, you could pause here and do that. So X for our EV and Y for our RV. Sometimes it's other labels, so it may not be X and Y, so you need to pick a label. Just make sure you know which is your EV and which is your RV. That's very important. When you're ready, what we'll do is we'll press menu, and it's actually the same set of buttons we press that we did when we found R, so when we find Pearson's correlation coefficient. So go statistics, then number 1, stat calculations, and then you're going to press on number 4, which is linear regression. So menu 414 is the fastest way if you can memorize those steps. Be particularly helpful next year in year 12. X list is obviously our EV, so I'm just going to press the sideways arrow and select X, and then tab Y list, select your RV, in this case it's Y, and then press enter. Just scroll down a little bit for me and you'll see A, that's our y-intercept, and B, there is our slope. So all we need to do now is write those numbers to the correct number of significant figures. Now, some of you might be looking at that A value and be thinking that's actually slightly different to what we got before. A was here, 40.9230, blah, 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 blah. Whereas this one was 40.93 recurring. Now, the reason that there's a slight difference is because when we did it with the formula, these values here, they were rounded off. So because we weren't using the exact values there, we got slight differences there when you go to your third, fourth decimal point. However, when rounded, we'll see it is exactly the same. So we'll write it now. So y equals, we'll go to 3 significant figures like we did before. So we'll have 40.9 for A. Since B is negative, I'm not going to write that. Again, we don't do that. We don't write plus negative. We write just minus. Oops. And then we've got 3.3. I'll put a 0 so it's 3 significant figures just like this one. And then it's X. Notice it says in terms of the variables given. So if there's an RV label is not Y, use the proper label, use its label. So I mean, if this was like number of hot chocolates and this was temperature, you should write number of hot chocolates equals blah, 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 something times temperature. So you have to use the right labels. Don't use Y and X unless you were given Y and X, as we were in this case. So just over here, 40.9 and 3.30. Now, there is another method which I can show you very quickly. You can get your equation from your scatter plot, because quite often you have to actually show a scatter plot first. So I'll press Control I, and then I'll get data and statistics. Down the bottom here, I'll click on that and I'll add the actual variable. So X, that's my EV, and Y was my RV. There's my scatter plot. As you can see, it does have a negative association because I got a negative R value and I also had a negative slope. So menu. For this method, you actually have to go to 4 for analyze first, and then 6 to regression. So menu 4, 6, and then 2. Menu 4, 6, 2 for this method. And there we have it. Now notice the calculator does something that irritates me greatly because look, it's got y plus minus. And I just told you several times, don't do plus minus. We don't write that. So you have to be careful if you're doing it this method because then you're going to be tempted to write exactly what's on your calculator screen. And I want you to try really hard to avoid that because this is not good. So we'll write just minus the 3.3x. So again, if you're looking for shortcuts, menu 462, so actually press number 4 on your calculator, then number 6 and then number 2. Whereas the other one is menu 4114, so I'll write that menu 414 for that particular method. And the other one is just in the box here. Okay. So I'll leave it there because you need some practice obviously with this. And obviously if you've got questions that you've thought of along the way, please make sure that you ask me in our next lesson.